let's say that you have a wave like this. So on the top is known as crest, and at the bottom is known as trough. So when you see here, we have this is crest and this is crest. When crest meets crest, then we have twice amplitude of the crest. Now you can see here, this is the crest. Okay, this is the crest, and this is another crest. Okay, this is another crest here. This one, another crest. Okay, now you can see the crest here meets another crest from the other source of wave here. Okay, you see that? That is the crest and mid crest. So the amplitude is twice. Okay, and then we have trough and trough. Okay, you see the dotted line here is the trough, and the dotted line here is another trough. And you see this is where the trough and trough meet each other. So you have another constructive interference, but the depth is twice. Okay, so actually along the line you can see crest and crest meet each other, and also trough and trough meet each other. Okay, this is another crest and crest. So actually they are on the same line, and it is known as antinodal line. Okay, and this is where constructive interference happens. Okay, constructive interference. And then you can see here where crest and trough meets, it will cancel each other, so there will be no wave at that particular point. So where is it? You try to find where crest and trough meets. It is here and here. See that? This is where crest and trough meets. They are also on the same line. So this line is known as nodal line. So there's no wave on that line. That is where the destructive interference happens. Destructive interference. Okay. And now we are going to look at the formula that we can use for this situation. Now this is also an interference, but this is the case of light wave, so you're not going to see crest or trough here, but you can see dark and bright fringes. Okay, bright fringes is the place or the point where constructive interference happens. Okay, the bright fringes here is where the constructive interference happens, but this is the case of light wave. And dark fringes, okay, the dark fringes here is where the destructive interference happens. Okay, now this is the source of light, and then you have Young's double slit. Double slits here, there are two openings, very small openings where light can pass through. Okay, and the light wave here are coherent because they come from the same light source. They are coherent. When we see it is coherent, means it has the same frequency. Okay, and also it has the same phase difference. The same phase difference. This is what we mean by coherent. The same frequency and also the same phase difference. So they will form fringes like this, okay, bright and dark fringes. And the question here, let's look at the question. Figure 5.65 shows Young's double slit experiment which produces a difference pattern on the screen. The distance between adjacent bright fringes is 4.5 mm. What is the wavelength of the light used? Okay, when you have a question like this, please extract all the information. In this case, we have okay, first of all, you can also write the formula. Lambda equal AX per D. Okay, remember this is the formula. Okay, the distance between adjacent bright fringes is 4.5, so this is the value of X. 4.5 millimeter is equal to 4.5 times 10 power negative 3 meter. Okay, millimeter is 10 power negative 3. Okay, and then what else information we have? We have here D. So D equals 3.0 meter. So you don't have to convert anymore because that is the SI unit. And then A is given in the question also. It is 0.4 millimeter. So this is equal to 0.4 times 10 power negative 3 also meter. And then you need to find what is the wavelength. So lambda equals AX per D. A is 0.4 times 10 power negative 3 times X. Okay, here is X. Here's the value of X divided by D. D is 0.4, D is 3 meter. So 3.0 meter. And then you can solve the problem. 0.4 exponent negative 3 times X. X is 4.5 exponent negative 3 divided by 3. Okay, so the answer it is okay, you can write in standard form. Okay, 0.0000006. Okay, so 1 2 3 4 5 6 7. So 6 times 10 power negative 7 meter. So that's the answer.